which one? 19, 23, and 43. Okay. Alright, let's go for it here. So starting off 1.2, working our way up. Hopefully this will take less than a half an hour or so. Let me come back to 1.2. And I'm going to go kind of quickly here. You guys tell me if I'm going too fast. But we'll try to keep on going here. 1.2, it's quadratic equations here. So at this point, 43 says solve each by completing the square. I don't know if we covered this one in the lecture here. The little 2 in front of r squared, there's a little problem. So let's go for it here. So we're going to keep this, leave a little bit of space, keep the 9 on this side. We're going to try to figure what we add over here to form that perfect square trinomial. Well, I got one little small problem. We can't do the perfect square, can't complete the perfect square until the number in front of r squared is just a 1. So what we factor out a 2. I think I did that before somewhere. Alright, so that means I'll just be left with an r squared. We got a little problem here. 2 does not factor out a 3. So what we do is we just write it as a fraction. There it is. Is that true? If you multiply the 2 back in, 2's cancel, and there's your 3r. Leave that still blank over here. But now let's go for this one here. So again, 3 halves, we're supposed to divide this by 2. The middle term has to be divided by 2, or we can actually just multiply by 1/2. In this case, you're going to get a 3/4. When you square it, what you're really adding into here is 9/16 on one side. Then you're going to have to add the equivalent to this side, except the problem is you're really technically not adding 9/16 to the whole entire left side. Because if you multiply the 2 into here, the 2 and the 16 are going to actually reduce, is that right? So you're technically only adding a 9/8 to this side. Therefore, we have to add a 9/8 to this side as well. Good there? Okay, got some puzzled faces looking at me here, so let's go for it. If I were to multiply the 2 back in, this would be a 2r squared. This would be a 3r, because of the 2's canceling. And if I multiply into here, technically what I'm doing here is I'm adding a 2 times 9/16, which would reduce this guy to a 1 and an 8. So technically what I'm doing is I'm adding a 9/8 to that side. So I better add the same thing to this side. Okay, so let me erase that so it doesn't bother us a little bit later on. And let's keep on going here. Let me bring this up to the top here. So I have a 2 on the outside. Now I have my perfect square trinomial. First of all, it's an r. So give me that r squared over there. And it's always the term that I almost squared. At this point, it'll be a plus 3/4 will give me. And let's simplify this a little bit here. Let's get this all underneath the same common denominator here. So 8 and 8 makes still this a 9. This is a 72. Everybody good there? So how about an 81/8? Put the in there. Okay. And the funny thing is, you're going to still have to divide by 2, or technically multiply by 1/2. And you're going to get 81/16. There's that 16 again, though. Comes back up. And of course, we can square root both sides. And again, don't forget plus or minus here. So r plus 3/4 is equal to, hey, those both of them are perfect square. That's cool. So that's 9/4. Is that right? Subtract 3/4 on both sides. I'm running out of space here. I'm going to have to go to the next slide here. So this should be r is equal to negative 3/4 plus or minus 9/4. Wait a little bit for you guys to catch up. Okay, so when you write it, this will be r is equal to negative 3/4 plus or minus 9/4. So we have to understand there's two different things happening here. There's a negative 3/4 plus 9/4. There's a negative 3/4 minus 9/4. So do those each separately. So this is 6/4. Finally reduced form is a 3/2. Over here, this would be a negative 12 over 4, or finally get ourselves a negative 3 as our final answer. Good there? Maybe? Again, could I have factored this down? I could have factored down. It would have been by guess and check method, but I would have got that down. Okay. Again, tell me if I'm going too fast, otherwise I'll just keep on going here. 1.3, bless you. 1.331. Now we get into complex numbers here. First of all, learning how to multiply them, add, subtract as well. So at this point I want to multiply this out, and again, no special form here, so what we do is we just make it into two of the same kind, and we do FOIL. So square root of 3 times square root of 3 is technically square root of 9, which is just a 3, because we square the 3's. This one, kind of fun one here. I do have to multiply the square root of 3 and a 12, except they're not the same kind of number, right? This one's a irrational, this one's a rational number. So I'm going to write as this, negative 12I root 3. Some textbooks like to put the square root in front of the I. They put square root of 3 and then the I in the back. I prefer this because then I know exactly that the I is on the outside. Again, negative 12, same thing happens here because the same exact factors. This one, let's do that in our heads a little bit here. Negative 12I times a negative 12I will be a positive 144, but it's going to also be an I squared. And I squared by the rules technically is a negative 1. So what happens here, I get myself a negative 144. Alright, then adding the common terms up, so 3 and a negative 144, how about a negative 141? And then the complex terms, those are like terms too, how about a minus 24I cubed 3? And again, this way is a proper way to write it. Some math textbooks would write it like this. Just whenever you write it like this, just make sure this little square root symbol, make sure that ends right before you start the I. Don't put the I inside the square root because it means something totally different. Right, so kind of make sure that's there. Okay, keep on going. Maybe. 49 is the next one. 1.3, number 49. 2 minus 5I over 4 minus 7I. Alright, we have to write this in standard form. Well, standard form has to be written like this, A plus BI. So no fractions, no nothing here underneath. A and B could be fractions, but there can be a rational expression. So we got to get rid of this value on the bottom. Right? The way we get rid of it is to multiply by its conjugate. In this case is 4 plus 7I. Whatever we do on top, we've got to do on whatever we do on the bottom, we've got to do on the top as well. Now what's so special about this is that the middle terms are going to cancel. So if you remember from Math 63, if you have two things that are the exact same opposite signs, but the same numbers, the middle terms cancel. So really what we got to do is just do this. Multiply that, gives you 16. Multiply these guys, gets you again that it's a negative 49I squared, which technically is a negative 49 times a negative 1, which is a positive 49. Alright, anybody 16 plus 49? Make me do it again here. 65, thank you. Okay, the top though, yes, we do have to multiply all that out and FOIL everything out. So 8 looks like a positive 14I. I gotta extend this out a little further. Multiply here, that's a negative 20I, and multiply negative 5I. Again, see if we can do this in our heads now. Negative 5 times 7 is negative 35, but it's I squared, so plus 35. plus 35 is going to be a 43 minus 6I all over 65. And again, what we learned is that these numbers have to be separate. You can't put something underneath a fraction, because again, a plus bi should be the final form. It's not a plus bi over c. That's not the final form. So in this case, we're going to divide the 65 into each of those, and then none of them reduce. If 43 and 65 reduced, then we would write that simplified form. So if this was a 5 instead of a 6, then I would reduce this down to 1 over 13i. Keep the 65 still over here. So it kind of just depends what you need to do there. Okay, good there. Keep on going. 61. Alright, 8x squared minus x equals x squared minus 3. Let's see, solve each equation. So for this one, once I see an x squared, especially if I also see an x, I'm going to simplify everything over and set equal to 0. That's the first step. So let's multiply through. Move everything over so that it's, let's see, plus 3 doesn't have a like term next to it. I'm going to write it sort of like right here. So that's 7x squared. Let's see, minus 8x plus 3. Okay, first things first, just real quick here, can I factor 7? I'm going to just try it just to see. 7x times x, those are prime numbers. 7 is a prime number, that's easy to do. 3 is also a prime number, except I have a minus in the middle. Plus 3, so that means I know both these have to be negative. Two different options here, right? So only two different options. There's either 1 here and a 3 here. That would make negative 21, and 1 makes negative 22. That's not going to work. So how about the 3 goes here, the 1 goes here. So that's negative 7, negative 3 make negative 10x. No, that does not work. Alright, so then I know I have to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, and then we simplify from there. Somebody simplify that for me right there. 64 subtract all of that. Perfect, thank you. Negative 20, that's over 14, so I know I'm having a complex number here. So 20 is 4 times 5, so that means it's a 2i root 5. Everybody agree there? Maybe. Good. Maybe sometimes. Okay, I'll do it. 20 over here. 20 is 4 times 5. That's a perfect square of 2 and 2. So 2 gets to go out, but because it's negative, the I gets to go out as well. Because by definition, this is what I is. I is the square root of a negative 1. Okay, separating them out. Let's see, 8 goes over here over 14, plus or minus 2 square root of 5 over 14i. Simplifying each one of those by 2, I guess, for this one. So 4 over 7, plus or minus, and this also by 2. That's a 1, that's a 7, so technically a 1 times root 5 is just root 5 over 7i. Sorry, it's all the way on the bottom there, but there's the answer. Done. Okay. 1.4, number 17. Let me put it over here, 23, just so I can remember the next one. Keep on going here. Almost a half an hour here. Let's see if I can speed up a little bit. Alright, 1.4 has to deal with all the other equations. We have rational equations, we got radical equations, and then we have equations with rational exponents, which means fractions in the exponents. Those are the other different types of equations from algebra. Okay, so whenever we have a rational equation here, what we have to do always off to the side is I have to ask what in the world can x not be? What's not part of my domain? Or we can ask this question. When does 3x minus 2 equal 0? When x equals 2/3, so I can't have a 2/3 as my final answer. And then I go over here, put the other denominator set equal to 0, subtract 2, divide by 3, and I got this problem. So if any of my answers come out to be a 2/3 or a negative 2/3, I can't accept them as answers, because they just don't make sense. It makes it undefined. Okay, two ways to do this. Whenever you see two fractions equal to each other, we know from Algebra 1, remember a long time ago, two fractions equal to each other, you can cross multiply, like this. That's kind of cool. The longer way is, what's my common denominator? X. 3x minus 2, 3x plus 2, right? You can still multiply through by common denominator, which would be 3x minus 2 times 3x plus 2 multiplies 6 plus 1, 3x minus 2. And again, 3x minus 2 times 3x plus 2 is multiplying the right-hand side. But notice when you do that, you're still cross-multiplying, technically, because these two will cancel off, and you're still technically multiplying x plus 1 times 3x plus 2. You're still multiplying these two, so you could just cross-multiply, save you a step. Over here, same thing happens here. 3x plus 2 is cancelled, so technically you're still multiplying 5x minus 4 times 3x minus 2. Alright, got some work ahead of us here. So 3x squared plus 3x plus 2x plus 2. Other side. Ooh, oh boy, 15x squared, is that right? Minus 12x minus 10x plus 8. Again, watch my arithmetic here, make sure I'm doing it correctly here. So 3x squared plus 5x plus 2, 15x squared, what is that, minus 22x plus 8? Okay, I can either move everything over to one side, or to the left, or I can move everything over to the right. You know what I'm going to do? I'm going to actually move everything over to this side. Minus 3x squared, minus 5x, minus 2, and I'm totally running out of room here. Globetrotters. Okay. Dink, dink, dink. Help me out here. 15 minus 3, that would be squared. Perfect. Negative 27x. Good there. Plus 6, and that is actually all equal to 0 in the front this time, because I moved it over to the right. You know, I don't like to see it on the right hand side. Can I just switch them over? I'm going to switch this guy. Set equal to 0. It doesn't matter. I can move it over to the other side. Everybody good there? First things first, before I start doing anything here, is there a greatest common factor? I think that's where the problem is. Those are trying to do it. As the number goes into 12, 27, and 6. 3. Perfect. 3 goes into that. Maybe this becomes this. And instead of dealing with it, we can technically, we're just going to divide through by 3 like this. And not having to do with that one there. Okay, so I'm going to, again, just check it to see, maybe possibly I can factor this down. Tricks of the trade, you guys ready for this one? know it cannot be 2x and 2. I know for sure. Because whenever you bring down this little 2 here, it has to be a 2 somewhere in here, right? This can never happen, or else I would have another factor of 2 that can go out in front. Does that make sense? The numbers, after you've taken off the greatest common factor, the numbers inside each parenthesis have to be, we call it relatively prime to each other. So I would not be able to factor in another 2. So, I know for sure, if I'm able to factor this down, it has to be a 4x and a 1. Also something I know, I can't place the 2 over here, because I would still be able to factor out a common value of 2 all the way in front of all this. So that I know for sure, and if I'm going to get a plus 2 here, I got minus minus. I know for sure the 2 has to go here. Ah, sorry, I'm forgetting my x, huh? Okay, like this, it has to be a minus here. And the 2 has to go here, the 1 has to go here if it does factor down. So let's check. Negative 8x, negative 1x makes negative 9x. Awesome. Love it when it works out. Okay. Set each of these guys equal to 0. How about add 1, divide by 4. This one will add 2. Everybody okay with those answers? Okay, add a little extra detail here, because again, people looking at me, kind of funny. It would be this or this, and again, add 1 to both sides. Divide by 4 gives you the 1/4. At this point, we just add 2 to both sides, gives you that one. Ooh, what numbers can we not have? Yeah, perfect. 2/3 and negative 2/3. Neither of those are that, so I accept both as answers. So notice a little subtlety in mathematics. Notice this is an or statement, which means one could be the answer or the other could be the answer. What happens at the end here, you're actually saying and. The answers are 1/4 and 2. Or you can say like this. However, the back of the book has it written because I don't have the answers here. Oh, this one does have the answer. Okay. So there it is. Notice the or changes it to an and because I can accept both answers as answers. The only time that does not happen if it's a word problem, and let's say we got a negative answer, and then you can't have negative distance or negative time, so then that scratches off. Or in this case, let's say one of them was 2/3. You'd scratch that off and say only 1/4 is the answer. Okay, that was 1.4. Moving on to 1.5. Oh no, hold on, we got 96. Okay, 96 part of the homework, is that right? Yes, no, maybe? An even problem, oh boy, how fun. Okay. Okay, so you're at sea in a motorboat at a point A located 40 kilometers from point B that lies, let me just draw it. So, no, I want to go hash marks here in this one. So there's point A. We go here, point C. And the hospital. Someone just got injured. Okay, then let's put in this one here. All that information tells us this. You are 40, what is it, 40 kilometers from shore. And what you're going to do is you're going to cut across as how fast as possible that you can. So there's 130 here from the hospital. So if this is x, this has to be 130 subtract x, because that's the distance remaining. Call the hospital on your cell phone to send an ambulance. Your motorboat can travel at 40 miles per hour, and the ambulance can travel at 80 kilometers per hour. 40 kilometers per hour. So, how far from point B will you be when you and the ambulance arrives simultaneously at point C? How fun. Cool, cool. Alright, let's go for it here. So first of all, I'm going to go like this. Distance from B. I should label this. This is B, this is C, and that's the hospital. there's my variable. Again, accounting for any other variable in the problem. I got to get this one too here. This is distance from, we would say, what, hospital? From hospital to C. There's that. Okay, and then the only thing that's missing, our route right over here. This is your distance formula right here. And that's Pythagorean theorem, isn't it? So that means 40 squared plus x squared would give us this, as long as we take the square root of it. So tell me if you guys agree here. This would be the square root of okay, and then we got to think about this right here. If you're traveling a certain distance, you guys remember this one from algebra? Distance is equal to rate times time. We'll see a lot of those inside the book here, just because it's physics, and you're going to always look at distance here. So if we're thinking about time, there's my distance being traveled, right? But I'm going at a certain rate, so then I'm going to want to do this here and think of everything in terms of time. So distance divided by rate would be the time that it takes me to travel this much. So go back over here, and let me put a different. So not to be confused with this 40, because this is not the 40. Let me read this here again. It says the motorboat can travel at 40 kilometers per hour. So now the time that this is traveling, actually let me do it like this here, just so not confused. Time would be 40 squared plus x squared divided by 40. Then it says the ambulance can travel at 80 miles an hour. So that means we have a time for the ambulance. The ambulance can travel, again, the distance it needs to travel divided by how fast it's traveling. Good? And there gives us the time that it's going to take to travel. Cool. Okay, so what we really want is we want the motorboat to travel this way, the ambulance to travel this way, and what happens is we get there at the exact same time. So don't we need our time to be the same? So we want the boat travel time and the ambulance time to hit at the same spot. So that's exactly what we're going to do. We're going to set this guy equal to this guy. We could have said actually time 1 and time 2, or time B for motorboat, time A for ambulance. But here's what we got. Finally, we have 40 squared plus x squared over 40 is equal to 130 minus x over 80. And that's what we need to solve right there. A little more complicated than we saw in algebra. Just a little bit. Alright. How do we solve? What I see here is I see a square root, first of all. Let's isolate the little square root, and from there then we can square both sides and keep on going. Good? But first of all, let me get rid of all the fractions here, because I don't like fractions. So let's see, cross multiply, would that work first? Let's cross multiply here, that's going to be, or you know what we can do is we can multiply by the common denominator. Let's do that. So common denominator 80. Let's multiply this side by 80. Let's multiply this side by 80. And what we got here is a 2 goes on the outside, so it's really 2 root 40 squared plus x squared is equal to, ooh, this one's not so fun. This is actually 80. Ooh, my pin stalled here. Okay, everybody good there? Cheat just a little bit here. Oh, sorry. Make a mistake here. 80's cancel, right? There you go. A lot better. That went away completely. that should be 130, subtract x, it stays like that, so it stays like this. Okay, got a little choice here. To isolate the radical, should I divide by 2 or should I not divide by 2? Only time you want to divide by 2 is if you can factor out a 2 out of here and divide it out. Can't do it this time. So multipliers on the side of a radical can stay there, and that's fine. We're going to do like this, and what's going to happen is that 2 still gets squared, so that 2 becomes a 4. But this radical here and the square actually cancel off, so now we're left with, you know, and let me actually simplify that already here. 40 times 40, anyone? 160 or 1600 is good. Alright, this is the fun part here. So this guy times itself. Again, there's a little bit of a shortcut here, but if I do that, that's going to be 13 times 13 is 169. I know that for sure. 2 zeros. Will that work? Subtract, and again, this is going to be a negative 130x, another negative 130x. So how about a negative 260x? Would that work? And then the negative x times the negative x is a positive x squared. So 16,900 minus 260x plus x squared. Alright, still not done yet. 6,400 plus 4x squared. Alright. Still going. What do we want to do? I think we want to set equal to 0 and factor, is that right? So subtract x squared, I'll subtract x squared here, subtract 16900, subtract 16900, add 260x here, so add 260x over here, and I'm running out of space again. And we're almost been an hour and homework. Alright, let's see if I got this here. This is 3x squared, I'm going to write that one put together, plus 260x, and then this guy. Anybody? 6,400 subtract 16,900. 10,500? Yeah. So minus 10,500 is equal to 0. Not good, not good. Okay, probably use a calculator here. The only thing I'm going to check for is, can 3 divide into 260? Can 3 divide into that? Anybody know the quick rule to check if 3 divides into numbers? What you do is you add up all the digits. So for this 10,500, you add 1 plus 0 plus 5 plus 0 plus 0, which is 6. If 3 divides 6, that means 3 will go into 10,500. 260, 2 plus 6 is 8. 3 does not go into 8, so no, 3 can't go into here, so I can't divide this out. Bummer. Quadratic formula, here we go. Big, humongous number, oh boy. So 260, so negative 260 plus or minus, and it'll be 260 squared minus 4 times 3 times a negative 10,500, 2 times 3, and I suggest you use a calculator. Just saying. Okay, I'm going to cheat a little bit here, okay? After you do the calculation for that, again, you got to simplify the stuff in here first. And what you come up with is you come up with two different answers. One is 30, and the other one's a negative 350 divided by 3 when you get that done. Again, try it on the calculator, make sure you get it. Actually, I should write it like this. Let me write it differently. I should get this, or x is equal to a negative 350 over 3. Alright, and there's a problem. Which Which one doesn't make sense? Okay. Yeah, you can't get there in negative 350 divided by 3 hours. Doesn't make sense. So that goes away. So you're looking at x is equal to 30. Oh, sorry, no, it's not in terms of time, it's in terms of distance. X is the distance. So 30, and we know that to be 30 kilometers. We're good? Let's go back to the problem here. What does the 30 mean? 30 means if we're going on the motorboat as fast as we possibly can, the rendezvous point for the ambulance and the motorboat would have to travel so that we are 30 kilometers from where we are in order to arrive at the same time, get on the ambulance, and keep on going. Does that normally happen? No. Usually, motorboat will go over here, then they call where they're at, and then go from there. But what tends to happen is, that's not a. I was trying to do a tower here. Tower there, a tower there, and a tower there. If you ever use your GPS on your phone, what's happening is sort of like the same thing. It's in order to get GPS, you have to have, for it to work well, you have to have 3 antennas to get your location. And what happens is, when you click on Maps on your phone and you click Find Me, right? What it does is sends a signal away from the phone like this. And once that signal hits here, and the signal's still going out, and then hits over here, by those 3 positions, it can figure out, oh, ding, 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 ding. It took this much distance to hit this tower, it took this much distance to hit this one, and this much distance, therefore, you are here on the world map. Sort of the same thing here. You're sort of getting distance in terms of time, and you're figuring out a coordinate, which is kind of cool, me think. Okay, good there. Even problem, you don't have the answers to those, so yes, I have to do them in class. And they're the tough ones, so yes, we should look at them in class together. Raise your hand real quick here if you got that.